So let's continue with this last part of the chapter on alcohols. We're going to continue and look at some reactions of alcohols. Now we'll look at oxidation, and we'll look a little bit, just briefly, at some of the biological redox reactions in the oxidation of phenols, and then the synthesis strategies. For this, you'll need to go to the preview and review video that I've already made. And so let's go ahead and start discussing this part. The oxidation of alcohols. You've seen the reduction to yield, the reduction of carbonyls to yield alcohols. You can also see the oxidation of alcohols to yield carbonyls. And that's what we will discuss next. Oxidation of primary alcohols, as you've already seen to some extent, can give you the aldehyde, and further oxidation then can give you the carboxylic acid. Here you've got one alkyl group, one alkyl group, one alkyl group. That is not possible if you have 2 or 3 alkyl groups. You can't, you're not going to break carbon-carbon bonds in these oxidation reactions. So if you start with the primary alcohol, you can go all the way to the carboxylic acid. If you have the secondary alcohol, you can go to the ketone. If you have the tertiary alcohol, you won't have oxidation at all because you don't have any protons to at the alpha position to be able to be removed. There's a large number of oxidizing agents that can be used for this. We're going to look just at a small number of the most common ones. The most common oxidizing agent has been chromic acid. Used to, you couldn't even purchase chromic acid to be shipped to you. It is exceedingly strong and dangerous. Used to, we would need to make this in lab, usually from the sodium dichromate salt, which is, of course, a solid, and mix it with sulfuric acid. And I just cannot tell you how strong that is. You know how strong sulfuric acid is. Chromic acid is much stronger. And so you have to be very careful handling it. And it's also called the Jones reagent. So you can have oxidation of the alcohol. It involves 2 steps. Notice here, this is the secondary alcohol. You have the carbon-oxygen bond. And so you're going to have the chromate ester formed here. And then notice once again, as always, you're converting the alcohol, the hydroxyl group, to a better leaving group. This is the common theme behind all of these reactions of alcohols. And so once you have converted this into a better leaving group, you can simply have water pluck off a proton, and the pair of electrons move in and form the pi bond, which constitutes the carbonyl pi bond. And so the chromic acid will oxidize a primary alcohol to the aldehyde and go on to the carboxylic acid. Chromic acid will not stop at the aldehyde. It will take you straight on through to the carboxylic acid. However, you can use a milder chromium reagent, pyridinium chlorochromate. This is a much milder reagent which still involves chromium, chromium ester, and you can generate the aldehyde. And because this is so much milder, it will stop at the aldehyde. So you have 2 oxidizing agents. You can where you can convert the primary alcohol to the carboxylic acid, or the primary alcohol to the aldehyde. And the secondary alcohol can be used to convert, can be used with either of those reagents to yield the ketone. But as you already know, probably chromium reagents are toxic and horrible for the environment, and so other oxidizing agents, which are milder, have been developed. And so this is the Swern oxidation. Dimethyl sulfoxide and oxalyl chloride form the active oxidant here. And so this is the active oxidant, the chlorodimethyl sulfonium ion. Chlorodimethyl sulfonium ion. And so here, this is your oxalyl chloride. You have attack by oxygen, O-, on the carbonyl of the oxalyl chloride. Then you have reformation of the carbonyl. The chloride departs, and so then that chloride then comes around and does a backside attack on sulfur, and you form carbon dioxide, and this group departs. So you can see with the attack here, you do have the backside attack, inversion of stereochemistry, and so now you have the chlorodimethyl sulfonium ion formed. Now, in the next step, using the chlorodimethyl sulfonium ion, we've used a secondary alcohol. Oxygen comes in, does a backside attack on sulfur, and displaces chloride. Now you can see that you had this very mild, relatively mild base, simply deprotonates the oxygen, and then simply deprotonates again. Okay, so now you have this called an ylide, where sulfur has a positive charge and the atom next door has a negative charge. So you have this anion and cation in the same molecule. And so the pair of electrons here on this carbon comes in, plucks off a proton, and the pair of electrons in the CH bond moves up to become the double bond of the carbonyl, and this is your leaving group. So dimethyl sulfide is the byproduct. And so you have transformed the secondary alcohol into the ketone. Now, I don't think that you would ever be asked questions about this mechanism, but it is good to see this mechanism because all of the steps in this mechanism are very common steps. And I think an important part of it is that the triethylamine it's a very mild base, plucking off the proton in both steps. The Swern oxidation also converts primary alcohols to the aldehyde. Now, as I said earlier, it's a very mild oxidation, and so it stops at the aldehyde. It does not go on to the carboxylic acid. Another very mild oxidation of alcohols is the Des-Martin periodane oxidation, abbreviated DMP. And it's a very mild oxidation, and so once again it converts a primary alcohol to the aldehyde. It stops and does not go on to the carboxylic acid. It also will convert a secondary alcohol to a ketone. And here is the reagent. I just don't think that you would be asked questions about that reagent, but we will go ahead and discuss it anyway. Notice that you have 3 acetates bonded to this iodine, And so what you're going to have is you're going to have two of the acetates will depart in the course of one oxidation. So we can go ahead and look at that. What happens first is you have the alcohol in the presence of the DMP, and that is, here you can see it reacting. And so the first thing that happens is the oxygen of the alcohol comes in and bonds to iodine. And notice you have 2 acetate groups on here now, along with the alcohol. And so you've lost one of the acetates already from your iodine, just in the course of this coming in and attacking iodine. When this comes in, when the oxygen here comes in and attacks iodine, you lose one of the acetates. So one acetate is already gone. And then this acetate plucks the proton off, and the pair of electrons moves in and forms the carbonyl, and then this second acetate departs in the course of that reacting. So this acetate becomes acetic acid. And so now you can see that this intermediate with a lot of arrows, a lot of movement going on, yields the carbonyl compound. And so again, this is mild, doesn't require high temperatures, while the chromium oxidations do. So this is preferred. Now, predict the product for this reaction. Notice you've got an aldehyde, an alcohol, and, this is a primary alcohol and a secondary alcohol. And so what would you predict from this? So if you're using chromic acid, this will oxidize all of these just as far as it can. Okay, so the aldehyde will be converted to a carboxylic acid. The primary alcohol will be converted to a carboxylic acid. And the secondary alcohol will be converted to a ketone. You won't be able to convert this to a carboxylic acid because carbon-carbon bonds aren't broken using chromic acid. Now, what if we used the Swern oxidation on this? What you would have is this does not go on to a carboxylic acid, and this will stop at the aldehyde, and this will be oxidized to a ketone. So you might want to practice, use this, and practice oxidizing this with all of the reagents that you've had so far. This will be a good little molecule for you to practice with. Now, we also have biological redox reactions, and so NADH is over here, and here's the reactive center, and these are the 2 CH bonds that are important. One of these will become involved in the reaction, and so this is the hydride delivery right here. It comes in and attacks at the carbonyl carbon. The pair of electrons moves out and plucks a proton, picks up a proton. And so this is where you have the alcohol. And in this way, NADH is converted to NAD minus. And so this plays an important role. You can also have the reverse, in which this picks up H minus and it converts the alcohol to the ketone. This plays a key role in metabolism, such as the citric acid cycle or the conversion of ADP to ATP. Now notice in the case of phenols, you have no alpha proton, just like in tertiary alcohols. So tertiary alcohols are not very reactive, but phenol can be oxidized because of the electrons here in the ring. You can carry out reactions on phenol, and it can be oxidized even without an alpha proton. So the phenol using and these reagents added together, remember, give you chromic acid. So the oxidation of phenol will give you benzoquinone. And when benzoquinone is reduced, you get hydroquinone. And then it can be oxidized back to oxidation. And these quinones interconvert with the conversion with hydroquinones is a key process in cellular respiration. And so this is shown on the next couple of slides. So, for example, if you look at these ubiquinones, you can see the quinone there. So here's the benzoquinone that we had and hydroquinone, and then here you see the benzoquinone again in the structure in the ubiquinones. And so here you can see the benzoquinone is being converted to the hydroquinone, and then step 2, the hydroquinone is converted back to the benzoquinone. And so this is the ubiquinone catalysis, and it is carried out by NADH being converted to NAD+. And so you can see the net reaction is NADH going to NAD+, and O2 and H+ being converted to H2O. So this is the overall reaction in that. Now, synthesis strategies. Some of these I have shown you already on the review sheets. It will be very good for you to review all of these by using those review sheets as I discussed with you. You know, I have provided some of these where you have the reagents to be able to convert an alkyne to an alkene to an alkane, and then here is once again your alcohol oxidation and going back the reduction of the carbonyl. This is a primary alcohol, and again the oxidation to the carbonyl and going back to the alcohol. You'll want to review all of that. So you can group these functional groups together in this way. I have changed the drawing a little bit from what's in your textbook, and I think that the way that I changed it here will make it have a little more sense, because the oxidation states of these are not the same. The oxidation states of these two are the same. And so to go from alkanes to alkenes, it's an oxidation. Alkenes to alkynes, it's an oxidation. Alkynes to ketones or aldehydes, that's an oxidation, as you can see. And then reduction here, these two are the same, and then reduction. So this is neither an oxidation nor a reduction. This one is reduction. This is oxidation. And in your textbook it says that going from in between these is neither an oxidation or a reduction. That's a mistake. Okay, this is an oxidation here, as I've shown. So you, if you get confused by what's in your textbook, this should help you. Come back and print this page out and look at this instead. Synthesis strategies. I mean, look at all the reactions here. There are a lot of reactions. And if you look carefully, the ones that are from this chapter, from chapter 12, are right in here. Okay? This is not really from chapter 12, and this is not from chapter 12. The parts from, chapter 12 are right in here. And even this is a review. Okay, so really it's these and the first top part up here. And I've got this all circled and drawn out and discussed, which came from which chapter, etc. In the preview and review video that accompanies this chapter. So it'll be really good for you to go back to that. Whoops. Okay, so this drawing is the same as what was on the previous slide. It's the same as this, except here all of the reagents are shown. And on this one, all of the reagents are missing. And so you should print this page off and then, as a test for yourself, try writing in the reagents at each place, and this will help you practice and learn your reagents. This is a good review for you, okay? This is a good review also. Okay, so that takes care of the reactions of alcohols and the entire chapter on alcohols. And so go back and review your the chapter and the reactions with the preview and review videos, and that should help you a great deal.